We know that the visible universe was once smaller and hotter, and it's expanding. We know that there was a moment when the expansion began. We know that that moment was about 13.8 billion years ago. For over 50 years, we've known of the cosmic microwave background radiation, which is also called the CMB. The CMB is the earliest thing we can see in the history of the universe. In fact, it's the remnant afterglow of when the universe began. The CMB presents a picture of when the universe was about 400,000 years old, which is when the universe was about 0.003% its current age. If we equate my current age to the age of the universe, seeing the CMB is like seeing a baby picture of me when I was 14 hours old. Man, I was a cute baby. However, while the oldest thing we can literally see existed 400,000 years after the universe began, we actually know about the conditions in the universe much, much before that time. For instance, at the moment which we can see the CMB, the universe had a temperature of about 2,700 degrees centigrade. But the universe is expanding and cooling off. At even earlier times, the universe was hotter than that. While we can't see the universe when it was much hotter, we routinely recreate the conditions of the early universe in huge particle accelerators like the Large Hadron Collider in Europe. When we smash nuclei of lead together, the temperatures are as high as 7 trillion degrees centigrade. One has to be a little more careful about the definition of temperature when talking about the most energetic collisions ever made. But when the LHC is colliding beams of protons, researchers create temperatures last common in the universe when it was 1/10 of a trillionth of a second old. That's 10 to the minus 13 seconds for the amateur scientist crowd. So these are all facts. If we define the moment when the expansion of the universe began to be time equals 0, we have hard data for times after 10 to the minus 13 seconds. That should impress the heck out of you. It still blows my mind, and it's what I do every day. But for all we know, there are still things we don't. For instance, there is that time period between time equals 0 and 10 to the minus 13 seconds. Science doesn't know exactly what happened during that time. And we don't know about time equals 0, and even less about what happened before that.